So perfect, guys. So those who are watching this session on YT also can respond. Am I audible? Okay. Yeah. Thank you, guys. So again, guys, welcome you all to iitiansgateclasses. And today's session is about aircraft structures basics, a demo class for Sam. And this demo class is for our May batch. Okay. This is for our May batch. Okay. Okay, all right. So admissions are open, guys, for GATE 2025-2026 aspirants, and we have different branches. Okay, and most of you are, or all of you are from aerospace engineering branch, and we have different courses to offer. Those who are watching this session in YT or have not enrolled for them details, we have Get Online Coaching, which is our May batch, and then we have recorded course called Target Gate course, and we have distance learning program along with Get Online Test Series. Okay. So, guys, we'll be discussing about aircraft structures basics, and today's topic is about basic elasticity in that. Okay, and this is very important topic in aircraft structures or in your GATE syllabus as well. And about me, myself, Dinesh, and I am organizer come chief mentor at IGC. Okay, and most of you know little more about myself already, so I'll not spend much time in that. So basic elasticity. So in basic elasticity, there are different topics mainly related to stress and strain. Okay, and in today's class, demo class, we'll be discussing a bit about stress, in stress equilibrium equation, compatibility equation, and Airy stress function, and related previous year's GATE questions, including a GATE question from GATE 2024. So, am I audible, guys? Everyone who are watching this session can respond quickly. Yeah. Now, guys, I'm asking one question. What you guys mean by stress? Anybody? Satvik, Mohit, what you guys mean by stress? So, guys, do you feel stress anytime in your day-to-day life? Do you guys feel stress in your day-to-day life? When you guys do feel stress, hmm? When you guys do feel stress? Anybody?
Sir, while submitting the workload assignments on deadlines.
Right, when you are overloaded, right? Whenever you are overloaded, you will feel stress, right? Same way, any structure, if it is loaded, it will undergo stress, right? So usually we define stress in a simple way, right? It's a internal resistance against applied forces. And what is unit of stress? The unit of stress, can anybody tell? What is the unit of stress? It's a Newton per meter square, right?
Newton.
Now tell me, what is the unit of pressure?
Newton per meter square.
So then what is the physical difference between stress and pressure? Both have same unit, right? Force per unit area, Newton per meter square. So what is the physical difference between pressure and stress? Anybody?
stress will act, sir, stress will act at a point.
Okay, stress acts at a point. Pressure also acts at a point, right? You guys have done like fluid mechanics, right? In
Yes,
water,
sir.
you will find pressure at every point, right? So what is basic difference? Physical difference. Anybody? So basically, pressure is what? A loading, right? It is an external load, right? Yes or no? Pressure is a loading, right? Everybody agree or not? Pressure is a loading. What is stress then? Resistance to loading. So it is clear, everyone? What is the physical difference between stress and pressure? That is one difference. Second thing, what? Stress is what? A vector, scalar, or something else.
The tensor.
Yeah, it's a tensorial quantity. Later we will see what tensor quantity mean also. But stress is a tensorial quantity. Okay, it's a second order tension. Okay. Now what about pressure? What about pressure, guys?
Scalar.
Yes, pressure is a scalar quantity. Okay. Everyone, is it clear? Yeah. Now you guys understand now the basic difference between stress and pressure. Everybody, yes or no? So I am asking one question. How
Yes,
many
sir.
of you were aware this simple exact difference between pressure and stress prior this class? Anybody was well aware? Okay. Others? If yes, that's good. If no, also no issue. Okay, so that's good too. So what is a tensor? See, I will explain in a brief. You know vector. So what is the vector quantity? Satvik. For a vector quantity, you need two things, right? For any quantity to have to be vector quantity, what? It need magnitude. It need what? Direction, right? For a quantity to be vector, what it need? Magnitude and direction, right? But in tensor, you need what? Magnitude, you need direction, and along with that, what you need? Reference plane. Okay. So you can say vector is what? Vector is a tensor of first order. Okay. Scalar is what? A tensor of zeroth order. So tensor means it's a mathematical representation of quantities, physical quantities. Okay, Satvik? So stress is what? Second order tensor. There are higher order tensorial quantity also, that if you go in vector mechanics or continuum mechanics, there people teach. Okay, Satvik? If you study continuum mechanics, then all those things will come in, curriculum. Okay, so let's move from here. Let's move from here. Stress, right? So stress usually denoted by what? Sigma or tau. Usually normal stress is denoted by sigma and shear stress by tau. And what is stress? Stress in general is what? Limit delta A tends to 0, delta P by delta A, right? What it mean? What it mean? It means your stress act at a point. Delta A tends to 0 means what, guys? Anybody can tell? In physics, delta A tends to 0 means what? It's a point, right? Yes or no? It's a point. So your stress act at a point, but it need what? Magnitude, direction, as well as reference plane. Now shear stress is denoted by tau and normal stress is denoted by what? Sigma. So what is normal stress? Normal stress is what? Limit delta A tends to 0, delta Pn by delta A. So guys, anybody, what is delta Pn? What is the delta Pn? It's a normal force to a surface or a plane. Suppose this is my plane, and on this, if there is a force which is like inclined, okay, inclined by theta angle. So there will be a normal component of this and there will be a shearing component of this. Okay. So this shearing component of this force which is inclined from this plane, okay, inclined from this plane is what? Normal component of this inclined force, which is what? Delta P, is what? Giving us normal stress, and the component which is along this plane gives us what? Shear stress. Okay, gives us shear stress. If you want to draw little more clear, then how it will be drawn, I'll just draw. Okay, so if you want to understand how this normal and shearing force, so you can take, this is like my in plane, okay, and perpendicular to this is what? You have another axis. Okay, now this inclined force, okay, this inclined force will be making angle with which axis? Can anybody tell? This inclined, you can say this delta P, which will make angle with which axis? Can anybody tell? If you talk about this XY plane, so this delta P should be making angle with what axis? With what axis? Can anybody tell? Aditya, can you tell? Eh? Mohit, you were saying something, right? See, your in plane axes are x and y. Now this delta P, which is acting, no, this is making angle with xy plane, but I am asking not with plane. I am asking about with which axis it will make some angle. Yeah, with x-axis, no. If it is making angle, yeah, in that way you can say with x-axis, y-axis. Yeah, that way you guys can say. But my point is what? This delta P is what? It is not in plane force. It is not in plane force. It is not, guys, in plane force. Okay? It is not in plane force. Okay? It is not a in plane force. What it is making some angle theta with this xy plane. Okay? Now, since particularly if delta P is not in plane, okay, that means it will have some angle with x axis also, some angle with y axis also, and some angle will be with z axis also. But in simple way you can understand one thing: there will be one component which is in plane component, and then there is a normal component. Okay, so you have normal stress and you have shear stress. Now guys, in basic elasticity, how you denote your stress? Okay, as I told, it is denoted by sigma ij or tau ij, or so what I said, your stress is denoted either by sigma or tau. Okay, sigma usually for normal stress and tau for shear stress. But when you come to mathematical notation, your sigma or tau both can be denoted as stress, any stress, along with what? I and j. Along with what? I and j. What is I represent? I represent the plane in which it acts, and what j represent? The direction in which it acts. Okay, so that is what the meaning of this sigma ij or tau ij. Now guys, when this sigma ij or tau ij is normal stress, can anybody tell when this is what normal stress?
So when alpha II or tau II, when both are same.
Yes, Satvik.
Sir, when both are same, like
What both are said?
sir, like alpha XX or tau YY, something like that.
So how you say? If I equal to j, then it is
Yes,
what? It is a normal
normal.
stress. Okay, and if I is not equal to j, then it is what? Then it is shear stress. Clear? Everyone, it is clear? So it is not like if I write tau xx. So what is this? Is it shear stress or it is normal stress? Anyone? Because in your gate exam, in some of the questions, okay, especially in some question in gate mechanical, they have confused. So tau xx is what? Normal stress. Okay, why it is normal stress? Anyone? Why it is normal stress, Mr. Satvik or Krutik, Mohit, Dhaneshwar, Chahid, Ashita, Saurav, Aditya? Why it is?
Because
Because
the
here you
stress.
can say I is equal to j. Now guys, same way I am asking, what about this sigma xy? It's a normal or shear stress? Hmm?
Shear.
Shear. Why? Because here in this case I is not equal to j. So that's how the notation is done. Now we need to discuss about direction or sign convention. So how the sign convention is done, guys, for stresses? Okay, so if you take your cube, three-dimensional stress system, okay, let's make a cube. Clear? It's a rough cube. Now suppose you are taking this face, and here this is what x axis, this is your y axis, and this is what z axis. Okay. Now guys, I am talking about this plane or this face. So what is normal to this, guys? If it is A, B, C, D. So what is normal to this? What is normal to plane A, B, C, D? Anyone?
Sir, X.
X axis, right? X is a normal to that. So what will be your normal stress here? It will be sigma. Then what is I? The plane on which it is acting. So what is the plane? It's a X plane. What is the direction? It's a X direction. So what is your normal stress? Sigma xx. Now guys, once you know your normal stress, you need to know about what? Your shear stresses. Okay, shear stresses. Now guys, how you decide the direction of shear stress? So it's a very simple funda. See, if your this normal stress is going in what? Positive x direction, so the corresponding shear stresses will also go in positive x direction. So first, what is your shear in y direction? It will be in positive y direction. Now what will be that? First, it is sigma. What is your plane? It is x plane. And what is your direction? It is y direction. So it is what? Sigma xy. Now second shear stress, which is along what? Z direction. So what it will be? It will be sigma, the plane on which it is acting, x, and the direction is z. Just a moment, guys. Okay, guys, so you guys can understand sigma xz, right? Now, guys, you all know, right? This x axis is representing what? The plane, right? Everybody knows this, yes or no? How you represent this YZ plane? Can anybody tell? YZ plane is represented by what? Anybody? The axis perpendicular to that, right? Which is what? X axis. Now guys, I am asking, how will you represent this XY plane? Anybody? XY plane will be what? It is Z plane, right? Perpendicular to what? That Z axis. So it is Z plane. Now guys, you have written stresses on this plane. Okay. Same way, I want to write my stresses on a plane. Which plane? This back plane. Now tell me guys, perpendicular to this plane. This plane is what? Suppose this is O, D, E, F and G. So what is perpendicular to that? This OEFG. Anyone? X-axis, positive or negative? It is a negative x-axis, right? The perpendicular to this is what? Negative. Now guys, what will be your normal stress on this? It will be what? Again, sigma x x. Clear? Yes or no? Now this sigma xx, tell me, it's a tensile or compressive? It's a tensile stress. Why it is tensile stress? Can anybody tell? Why it's a tensile stress? Because this stress is going away from your surface, right? Any stress which is going away from your plane or surface is what? Tensile stress, right? It is going in negative x direction, but it is going away from surface, right? So it's a tensile stress. Now guys, you know this sigma xx. Now tell me, what will be corresponding shear stresses? Anyone? What will be the corresponding shear stresses? In what direction? In what direction? The corresponding shear stresses, yes, it these will be in respective negative axis direction. Means your sigma xy will be downward and your sigma xz will be in negative z direction. Clear? Everyone, is it clear? So that's how we decide sign convention for stresses. If your stress acting in positive axis direction, then means normal stress is acting in positive axis direction, then corresponding shear will be also in positive axis direction. And if your normal stress is acting in negative axis direction, then corresponding shear will be also in negative axis direction. Okay. Now guys, so if you write your stresses on a three-dimensional body, it will look like this. Everyone can see this. On all the 6 plane, we can see how your stresses will be acting. Everyone, is it clear? So you guys can see now total how many stresses you guys can see on this cube guy. How many total?
18.
18, huh? Total how many you can see? Total, if you see, this is what? Infinite simul small particle, means it is at a point. So how many you guys can see? There are total 9. There are total 9 stresses, which are what? Sigma xx, sigma yy, sigma zz. These are what? Normal stresses. Okay. And then you have what? Tau xy, tau yx, then tau yz, tau zy, then you have tau xz and tau zx, right? So total 9. But out of 9, how many independent are there? So total we have how many? Total 9, and out of that 6 will be independent. Why 6 will be independent? Because we will get from equilibrium equation tau xy will be equal to tau yx, tau xz will be equal to tau zx, and tau yz will be equal to tau zy. Okay, so this is about three-dimensional stress system. Now this three-dimensional stress system you can write in a matrix form. So you can write it is sigma xx, sigma xy, sigma xz, sigma yx, sigma yy, sigma yz, and sigma zx, sigma zy, sigma zz. Clear? So row indicates plane and column indicates the direction. Okay, and out of these 9, 6 are independent. Clear, everyone? Yes or no? This three-dimensional stress system. Okay. Now, guys, further I will not go in stress transformation and other things. We'll move to next is what? 2D stress system. So for 2D stress system, you can see this is what my xy plane. So on this 2D stress system, you can see here you have sigma xx, right? So corresponding shear, since it's a positive x direction, so corresponding shear in positive y direction. You can see this is sigma xx. It's a positive stress, normal stress going in negative x direction, so corresponding shear in negative y direction. This is sigma yy, it is going in negative y direction, so corresponding shear in negative x direction. So this is how you write 2D stress system. In matrix, how we write? It's a sigma xx, sigma xy, sigma yx, and sigma yy. And we know here your sigma xy will be equal to sigma yx. So your sigma ij can be written as what? It is sigma xx, sigma xy, sigma xy, and sigma yy. So how many independent stresses here, guys, for 2D stress system? How many independent stresses? How many? 2 or more. For 2D stress system, how many independent stresses? Anybody? How many independent stresses for 2D stress system? There are total 4, but out of 4, independent are how many? 3. Which all those 3? Sigma xx, sigma yy, and tau xy, or we call sigma xy. Clear, everyone? Why 3? Yes or no? Okay. Now you know 2D stress system also. So next is what? Equilibrium equation. So here I am not going to do any derivation, guys. I'll explain what is equilibrium equation and get question. So you know, in a body, in a structure, your load will be varying. If you move from one point to another point, what is going to happen? Will your load will be same? Will your load be same? No, right? The load will be varying. When your load is varying, what will happen? Your stress will be varying. But in a body, what has to be there? There will need to be a equilibrium of forces, right? Yes or no? So if your forces are in equilibrium and stresses are what? Guys, stresses are what? Resultant of forces, right? Yes or no? Stresses are what? Resultant of forces. So if you multiply your stresses with what? Area, you get force, and those forces would be in equilibrium. So on a 2D stress system, what all stresses you have? You have normal stresses, you have shear stresses, and along with that, if you take any body, there will be some what? Body forces, right guys? Yes or no? Why body forces? Can anybody tell? On any body, why body forces acts? On any body, why body forces will act? Due to gravity. Yes. Okay. Due to gravity, right? Because any structure will have its own mass, right? So that mass into gravity will be what? Body force, right? Now here for this 2D stress system, we are considering capital X and capital Y are body forces per unit volume. Body forces per unit volume, and you have stresses, which is what? Sigma xx, sigma xy, and sigma yy. These are varying along what? X and Y direction. So this variation is taken from what? Taylor series expansion. This variation is taken from Taylor series expression. Now you can see here it is sigma xx. This sigma xx is changing along x direction is what? Sigma xx plus dou by dou x into sigma xx multiplied by the distance over which it is changing. Same way, this sigma yy, you can see changing along y direction. How? It is sigma yy plus dou by dou y of sigma yy into dy, right? Same way, the variation of shear stresses also you guys can see. Okay, so these are from Taylor series ex- Taylor series expansion. Now guys, if you take the equilibrium in x and y direction, the force equilibrium, what you will get? You will get two equations, right? Yeah, those two equations are what? This dou by dou f dou by dou x of sigma x plus dou by dou y of sigma yx plus capital X equal to 0. So this is what? One equilibrium equation in x direction. Same way, you have dou by dou y of sigma y plus dou by dou x of sigma xy plus capital Y equal to 0. Now guys, here one thing I want to tell. We have written here sigma x and sigma y. What these guys? What are these? These are nothing but what? Sigma xx and sigma yy. Guys, don't get confused. If you are writing only one suffix, that means it's a normal stress. If you are writing I is not equal to j, like sigma xy, sigma xy and sigma yx. These are shear stresses. Now guys, this equilibrium equation we can also write in this way also, right? Simpler form. What is that form? In a simpler form, to remember what it is sigma xx comma x plus sigma yx comma y plus capital X equal to 0, and this is sigma yy comma y plus sigma xy comma x plus capital Y equal to 0. Clear? So these are two equilibrium equation for 2D stress system. Now guys, I have not done here derivation. It is coming from what, Mr. Shatwik? It is coming from force equilibrium. Sigma fx equal to 0 and sigma fy equal to 0. If you do for this given stress system, you will get that. Okay, force equilibrium means what? If you multiply these stresses with area and take equilibrium along x and y direction, you will get those equation. Okay, and before that, if you take moment equilibrium for this, if you take for this stress system moment equilibrium about which axis? About z axis. About moment equilibrium, if you take about what? Z axis, sigma mz, if you do, you will get these conditions. Okay, these conditions are what? Complementary nature of shear stress. Satvik, are you clear why this? You are telling why this differentiation is there, which is what? Dou by dou x sigma xx plus dou by dou by dou y sigma yx plus capital X equal to 0 is one of the your equilibrium, right? So are you clear or not yet why it has come in differential form? Equilibrium equation. It is just from equilibrium in a simple mathematics. How it has come? You can see the previous figure. If you see this previous figure, I'll just give the sigma fx equal to 0. I'll just show by sigma fx equal to 0. Just can you try, Satvik, here? If you take sigma fx equal to 0, take it. What you see, the force in x direction. So which are forces? There will be force due to this sigma xx, which will be what? It is going in negative x direction, so it is minus sigma xx. Now area will be what? It will be dy into 1, because whenever you take 2D stress system, you consider thickness as unit. Now another force is what? Due to this stress, but it is going in positive direction. So it is what? Plus sigma xx plus dou by dou x sigma xx dx multiplied by what? It is dy into 1. Now guys, another force will be due to what? This shear stress, and it is going in negative direction, so it is what? Minus sigma yx into what is the area? This dx into 1. Clear? Now this shear stress is going in positive direction, so the force will be positive, so it will be what? It is sigma yx plus dou by dou y sigma yx into dy. Now area is what? It is dx into 1. Clear? Now apart from this, what force, other force you have? You have body force. So body force will be what? It will be added, so it is what? Capital X into dx into dy into 1. So that means this is what? Volume, and this is equal to 0. Now you can see this will get cancelled, this will get cancelled, right? And throughout you can take dx dy out. Clear? So you get this equation. So this is what your one of the equilibrium equation for 2D stress system. Okay, same way you can write your equilibrium equation in y direction, which will be what? Dou by dou y sigma yy plus dou by dou x sigma xy plus capital Y equal to 0. So it is your equilibrium equation in what? In y direction. Okay. Now we have discussed about 2D stress system. So I can write equilibrium equation for 3D stress system also. Similarly, how you can write? There will be additional z term. So you can see here, this is for 3D, the additional dou by dou z sigma zx is there. Same way, here this additional dou by dou z sigma yz is there. And then in z direction, what you have? Dou by dou z sigma zz plus dou by dou y sigma yz, and then dou by dou x sigma xz plus capital Z equal to 0. Clear everyone about this equilibrium equation? Yes or no? Anyone have any doubt? Those who are watching this session. Aditya, is it clear? Everything? Yes or no? So this is just demo class. I am not going in derivation part. Just I want to tell what you guys mean by equilibrium equation here in basic elasticity. Quickly guys, respond yes or no. Clear? Okay, thank you. Let's take one gate question in recent year. So what is the question they asked in one of the previous gate paper? The component the component the components of stress in a body under plane stress condition in the absence of body forces is given by sigma xx equal to ax square, sigma yy equal to 12x square minus 6y square, and sigma xy equal to 12. Find this coefficient a such that body is in equilibrium or body is under equilibrium. Guys, can you try this question quickly? What is the answer, Aditya? Okay guys, so let's solve this question. We'll see. So we know guys, in the absence of body forces, what is your equilibrium equation? Your equilibrium equations are what? Sigma xx comma x plus sigma yx comma y equal to 0, and then you have sigma y comma y plus sigma xy comma x equal to 0. These are your equilibrium equation. Now guys, they have given sigma xx, sigma yy, and sigma xy. So take the first equation and then find out guys what dou by dou x sigma xx. So what it will be, dou by dou x, and what is sigma xx? They given ax square. So when you differentiate this with respect to x, what you get? You get 2ax. Now guys, what will be dou by dou by dou y sigma xy? It is dou by dou y. What is sigma xy guys? It is given as 12x square minus 6y square. So 12 x square minus 6y square. So what you get from here? What you get guys? You get what? 0 minus 12 hmm? 0 minus 12 y. Okay, no, no, wrongly I am doing. Sigma xy is not 12. This is here wrong. That is sigma yy. Sigma xy is what? It is 12xy. It is 12xy. So guys, substitute 12xy here, and when you differentiate with respect to y, what you get? 12x. Now what is your equilibrium equation? It is sigma xx x plus sigma xy y is equal to 0. So what you get? 2ax plus 12x equal to 0. So from here a equal to minus 6. Clear everyone? So what is a? So a equal to Aditya. Earlier we took sigma yy instead of sigma xy. So be careful guys. This kind of mistake happens in exam. So a is minus 6. So minus 6 is the answer. Now guys, second equilibrium. If you check second equilibrium equation, which is what? Sigma yy comma y plus sigma xy comma x equal to 0. So that means if you check second, what you get? If you differentiate this with respect to y, what you get? You'll get minus 12 y, and if you differentiate this with respect to x, you will get plus 12y, and this is 0. What it means? It is 0 equal to 0. That means this is satisfied. Clear? So this is not required. I am just doing it is for check. Okay, means your given stress system must satisfy both equilibrium equation in x directions also, y direction also, then only your system is in equilibrium. Clear? So that's how the gate question comes. So that's all from today's class guys. I just took it to explain you guys how we start and the kind of question comes in gate exam. Okay, from simple basics. Clear everyone? Everyone, is it clear? Yes or no? Okay, guys, then that's all from today's class. Okay. So thank you guys for watching this session. Okay. And I just took some simple basics about stress, how we, do not sign, notations for stress, and then sign convention for stress, 3D stress system, 2D stress system, and equilibrium equation. So thank you guys for watching this session, and those who have already enrolled, they can attend regular class from tomorrow, and those who have not enrolled, they can enroll in coming days for classes. Yeah, thank you all. Any doubt, guys? Any doubt, guys, for about classes or about this today's class? Any doubt? How was class, guys? Was it okay for you all? Okay, so we'll try to understand everything in structures from basics, and not try to mug up anything. Try to understand every sign convention, what is equilibrium, how we do, and then you'll able to solve all the related question easily and quickly. Yeah. So thank you guys.